So welcome to Durham. My name is Andy Hughes. I'm the admissions tutor. I've been doing this admissions job for 22 years now. And I have a 22-year-old son. You can work out the connection. Okay. So what I'm going to do is I'm going to talk to you about chemistry generally and chemistry in Durham. Okay, so this is June. We're quite early on in the admissions cycle. Yes, I have a 22-year-old and a 21-year-old and a 19-year-old son. This time, 2 years ago, I was sitting here, not for chemistry, for other subjects. So I know the decisions that you have to make at a particular time of the year. So I'm very deliberately going to take a little bit of a step back to begin with from let's try and persuade you to come to Durham to do chemistry, and let's think about going to university to do chemistry to begin with. So I'm assuming that you're looking at multiple universities, that you've come to Durham today and you're going to Bristol tomorrow. I know it's Bristol tomorrow because we had a member of staff in Bristol in the department yesterday. So I know that. It's also Bristol today, and I'm assuming you're not doing to Durham today and Bristol. So it's the time of year for going and looking round and trying to pick where you want to be, what course you want to do. I'm going to try and give you just a little bit of my understanding of what you should think about when you're making this decision. I should also say, in the context of this, I've spent the last 10 years working as a consultant for the Royal Society of Chemistry, dealing with professional accreditation of chemistry degrees. So I've seen the content in the last 10 years, half of the UK's chemistry degrees. So I think I probably know more about the structure of chemistry degrees than almost anybody else. That's kind of unfortunate. Okay. So in terms of thinking about where you're going to go, you need to think about the entry grades, the entry standards, the entry subjects. That does impact on the students who are there. It impacts on the course that you're going to get taught. Come to a slide later on, we want A-level maths. That does impact on what we can teach. There are universities that do not require A-level maths, and that impacts on how they teach some aspects of physical chemistry. We'll talk about the entry standards later on, but the entry standards define the other students that are going to be around you studying a degree. We're going to offer you, I think, a straight chemistry degree. I'll talk a little bit later on about what we're going to do at the edges. But you could go and look at a university that offers a degree in medicinal chemistry, a degree in pharmaceutical chemistry, a degree in chemistry and materials, chemistry and aerospace engineering if you're going to work on materials that are going to have particular applications. Okay, so in terms of thinking about where you want to go in terms of those specialisms, understand why you want to go and do those specialisms. I'm not saying they're right or wrong, but you need to make an informed decision about what it is that you're picking when you're picking a specialist degree. So yeah, in chemistry in particular, there are medicinal chemistry, analytical chemistry degrees. We also get degrees where you study two subjects, and to get the vocabulary correct, you can do chemistry with another subject. With means 75% of the major subject. So chemistry with pharmaceutical chemistry means it's mostly chemistry with a bit of pharmacy. And you also get degrees that are chemistry and another subject. So we have a degree in chemistry and biology, chemistry and physics, chemistry and maths. They're half and half. One of the things that people want to do these days is to go on placement. So you will find that degrees are offered where there's an opportunity to do a placement in industry, a placement overseas, which could be a project overseas, or it could be studying in a lecture theatre like this in an overseas university, where the language might be English, it might not be English. You could be looking at a placement that counts part of the degree. You could be looking at a placement that is what I would call intercalated. It does not count as part of the degree. It's non-credit bearing. You could be looking at placements where, if it's credit bearing, it's the third year, or it's the year between second and third. It's non-credit bearing. You could be looking at placements where it's the fourth year, or the year between third year and fourth year. And go on with my accreditation hat on, just don't ask about Scotland because you're just going to add another one to these how complicated because they start at a different point. I think the other thing to say in terms of what you're doing now, going around and looking at cities, is it's always beautifully sunny, warm and dry in Durham. It doesn't snow, it doesn't rain, doesn't get too hot, doesn't get too cold. Marketing department will edit absolutely everything out of that before the video goes online. But I think it's important that you do spend time now, this month, next month, over the summer, going and looking at places that you're going to enjoy living for 3 or 4 years of your life, because it's going to be an important part of your development as a person. And I think the other thing that you want to do is, in picking your degree, do decide what you're going to do afterwards. Make sure you pick a degree that's going to give you equivalent employability. And if I'm trying to sell you a dumb chemistry degree, I'll actually tell you you're probably better doing a broad chemistry degree and working out what you want to do when you've graduated than having some narrow focused idea now on something that doesn't actually recruit many people into time and careers. But be sensible. Think about what you're going to do. Take the time now to look around at some places and decide what it is that you want to do. Okay, that's my broad background here. Now let's focus a little bit more on Durham. So why should you come to Durham to do chemistry? I guess every university probably offers a slide like this. We've got good research. Everybody's got the same slide, okay? So here's the research that we do, and it means that we're going to offer you a curriculum that's taught by world-leading academics. This is it's a mobile phone. It's still working while in water. And this is an old photograph. This goes back probably 10 years. Right? My wife had a phone that looked like that more than 10 years ago. It's not a state-of-the-art iPhone. But that mobile phone is still working in water because it's coated with a very, very thin coating of a polymer that's water repellent. And absolutely every part of the phone is covered in this water repellent molecule. And the molecule is put on there by some technology that comes from a company called P2I. And P2I is a spin-out company. It's a spin-out company from Durham, from the researcher Professor Badial. And I think I'm looking now at Professor Badial's office. It is literally the other side of the coffee here. Okay? So he had a research grant probably 15 years ago, more than that, actually originally funded by the Ministry of Defence, probably to work on better Gore-Tex. And you can understand why the Ministry of Defence might have wanted better Gore-Tex. To put a water repellent coating on fabrics. 85% of the UK's hearing aids are coated with this technology. Mobile phones, Timberland shoes are coated with this technology. Okay? We don't make mobile phones in Durham Chemistry. We don't even make the machines that put a water repellent coating on mobile phones. But if you were here tomorrow, Professor Badial's actually doing lectures to the students tomorrow, to the open day tomorrow, on the technology that he's developed. The reason why he's not doing them today is because he has a secondment at the moment. He's currently the Chief Scientific Officer to the Welsh Government. And he's probably somewhere between Cardiff and here at the moment. So we do research here that makes a difference, and where we're going to teach you about it in our lecture courses. I think as I said, you need to pick somewhere that you're going to spend 3 or 4 years of your life that you're going to enjoy living. Jokes aside about the beautiful weather in Durham, we are going to offer you a course that's academically rigorous and challenging. That's a bunch of very clever words, mum and dad, that mean we're going to push them. The people who are going to do the pushing are very friendly and very approachable. There's an opportunity to go and meet some of them upstairs. One of them is currently making ice cream with liquid nitrogen. I'm going to be at the front of the queue when this lecture finishes. And the people who do the teaching, we do it with an open door policy. We are happy to meet our students. You will not find on my office a little sign that says Dr. Hughes is available on Tuesday afternoon between 2 o'clock and 3 o'clock. If I'm in my office, you can come and talk to me. The other thing about Durham is that we're going to offer you a collegiate environment. We have colleges. We'll come back to what that means. This is a very beautiful place to live. Okay, you may choose not to apply here. You may choose to apply and go somewhere else. Use today to have a look around because this is a very beautiful place to live. In terms of the university, there's a whole bunch of things that our students get to do, which I think people find attractive. So something like 3/4 of our students get involved in sport. Now that could be playing for the college fifth team, or it could be an international. Okay? College fifth team probably only ever plays away matches in Dublin over Easter. That's one level of sport. At the other level of sport, I had two of my departmental advisees, one of whom currently has a county cricket contract, and he's doing that at the same time as doing chemistry. The other one actually is taking a gap year next year because he hasn't managed to get a contract yet, and he's working on getting a contract. We've also had to rearrange exams for the Olympic rowing trials for Norway. So we've had people who played sports at all kinds of serious levels. There is this thing, a league table of British University sports, and you won't be surprised to be able to learn that Loughborough is number 1, Nottingham is number 2, we're number 3. But if you take out all the individual sports and just look at team sports, we actually beat those two. Okay? This university is very proud of its sporting excellence. But it's not just sport. We've got theatre companies, music, charity work, whatever you want to do. This university provides, because we have colleges as well as the central university, there's a very supportive environment for getting together in small groups. We also, as a department, have begun to recognise the things that are important in terms of equality, diversity and inclusion. So in the last year we've run activities for Black History Month. This is our departmental coffee room where the ice cream is currently being served from the right-hand side. This is our departmental coffee room on International Women's Day, putting together jigsaw puzzles of women who made a difference in science. We have an Athena Swan Silver Award. This measures our contribution that we've made to reducing barriers, in particular for women in science. It's an opportunity for students to get involved in our consultative committee, and we have a committee that's working on not just decolonising but diversifying the curriculum, how we teach what we teach and how we deliver it. And then you're going and looking around at half a dozen universities, trying to decide where you want to go. What should I tell you that's different about Durham? What's unique about us? We offer students in first, second and third year the opportunity to pick their modules. Now, other universities do, but I think we give students more choice of modules than any other university. And I'll show you the choice later on. And I'll also say there's plenty of choice, but if you're scared of choice, I'll give you a default. Okay? So one of the things that's different is lots of elective modules, lots of choice. Lots of universities you could go to, and the chemistry department will talk about how they work with biology, or how they work with physics, or how they work with maths, or how they work with engineering, or how they work with materials. I think we probably work with all of those in a way that no other university works with all of them at the same time. Okay? So we work at the interface with cognitive disciplines, lots of them at the same time, which means that you can come here and do a degree in chemistry just think, I'm a boring chemist. Well, you can also work with the biologists, or you can also work with the physicists without having to move to another university. We'll come back later on to the structure of the fourth year. So we offer the students the opportunity to do a research project, like everybody does. We can do a research project in Durham. We also offer you the opportunity to do that research project in the industry overseas. So our placement option is the fourth year. There are 2 or 3 other universities that do that as well. Most universities, the placement option is at earlier stages in the course. Okay? And there are merits in that we might come back to later on. And as I've already pointed out, we have colleges. Colleges provide a small group environment and a very supportive environment. So do I try and get the 2 lined up? No, get that one. And that one to get back. Okay, so we have 4 different chemistry degrees. Actually, we've got 1 chemistry degree. So you're going to apply to Durham, you're going to spend lots of time deciding which one you're going to apply to. And actually, the first 2 years are exactly the same. There is no difference between our degrees for the first 2 years. So don't feel that you have to make a decision and that you're bound to it. There are plenty of opportunities to change course, and there are plenty of opportunities to realise which one you want to be on. So we offer a 3-year course. We offer a course where you do a project in your 4th year. A project in Durham, a project in your 4th year in industry, or a project in your 4th year as an overseas university. The percentages are applicants, but one of the things I want to make clear is you can change course. When you arrive, end of 1st year, that's next week's job. End of 2nd year, that's next week's job. Beginning of 3rd year, that's October's job. Plenty of choice. How should you make that choice, though, if you want to think about it? We would encourage people to do a 4-year course if you want to be a chemist in any way at all. So if you want to go and work in industrial research and development, companies want the research experience of the 4-year course. If you want to do a PhD, and about a quarter of our graduates do, then UK PhDs really need you to have done a 4-year course. One of my colleagues who's here today she was one of our undergraduates. She then became a school teacher, and she's now back working with us. She would say that the next generation of teachers who are going to teach A-level chemistry need to know what research is about. So if you want to become a school teacher, do a 4-year course so you get the research project before you go and become a school teacher. Any kind of career as a chemist. Don't shut the door on us, please. Any kind of career as a chemist, do a 4-year course. We would recommend you do the 3-year course if you want to do a degree that demonstrates your literature knew it and your aspiration is to go off and do something else. Whether you've already decided to do banking, marketing, consultancy, whatever. Okay, that's the background that we would recommend for a 3-year course. The career ambition we would recommend for a 3-year course. As well as chemistry, in Durham we have this other thing called natural sciences. So chemistry's got about 40 odd academic staff. Natural sciences is run by one person and some professional support staff. They take the modules that we teach in academic departments and package them together to give degrees. So we have joint honours degrees, that's half and half. I always call it chemistry and biology because chemistry is more important to me, but actually the university does it in alphabetical order. So we have a 4-year course in chemistry and biology, chemistry and physics, chemistry and maths, where you do half and half, and in the final you do a project which could be in one subject or the other. In chemistry and biology you have 2 supervisors in the final year, one from each department, so we run a joint project. We have a 3-year program in the same subjects. We also have students who come to Durham and mix together multiple subjects over 3 or 4 years. And if you want to know more about that today, then go and listen to James talking about natural sciences. Okay, so let's think about how we're going to teach chemistry and what we're going to teach. We've got students who come to Durham having done every different A-level specification, IB, Scottish Advanced Tyres, overseas qualifications. We've got to get them all up to the same speed and then build on it. So these are the material, or these are the courses that we teach in 1st year. And we've largely got modules in order to be able to offer content for the natural sciences students. Okay? So chemistry students doing all of this. We begin with they all run at the same time. We have a module called Core Chemistry 1. It's got 30 credits, you're doing a total of 120. It has 4 lectures a week and 1 tutorial per week, and we teach in organic, and physical chemistry. I give the first 11 lectures on atomic structure. I start from A level, and by the end of lecture 1, I'm a long way beyond A. Okay? We go fairly quickly. And after I finish, then the organic chemists start at the end of A level, and they go probably even quicker, actually. We want to build on the skills that students have in mathematics. We also, if we want to build a degree where we're going to work at the interface with physics, at the interface with biology, we need to make sure that every student has got some background vocabulary in physics and biology. So this module has got a very long title called Mathematical and Experimental Tools Required in Chemistry. It's a bit of a mouthful, but if you look at it, that's METRIC, metric. One of my colleagues took about 10 minutes coming up with that, but he's the kind of person who does crosswords in coffee breaks, right? Okay. So here we're going to teach how to use the maths you've already got and a bit of new stuff to apply it to physical chemistry. We're going to make sure you understand physics, make sure you understand biology, and we're going to teach them analytical chemistry. So we've got natural scientists doing core chemistry 1 and metric, and we've got natural scientists just doing core chemistry 1. By and large, it's just chemists doing this module where we're going to teach you about polymer chemistry in the ionic solid state. And then you have 2 modules of practical chemistry. You can go and have a look in the first year teaching lab after I've finished. So that lot adds up to 80 credits. As a chemistry student, you have no choice, you're doing that. And then we give you some choice on top of that. And this is the point where I'm going to show you probably a longer list of choice, I would imagine, than you're going to find anywhere else. We offer a module called Molecules in Action. I would call it Chemistry for All. It's taken by anybody who's got an A-level in chemistry. So we have biologists doing it, mathematicians, engineers. Chemistry students do that. You can go and do biology modules. Most of the biology modules are very molecular. So you don't need A-level biology. The alternative is A-level chemistry. So you can do lots and lots of different biology modules. You can go and do maths modules. We tend not to let you know about the maths modules that the maths students take. They're very strange people, maths students. I've got 2 sons who are doing maths modules. We try to encourage you to do the maths with the physics students or the maths with the engineers. It's a little bit more accessible for chemistry students. You can go and do other things from other science departments. Sports science has got a module that's getting increasingly popular in sports psychology. We have students who go and do modules in languages. The university is very keen to encourage students to do languages. So you can do this list from scratch, from GCSE or AS, and you can do this from A-level, A-level plus a level, A-level plus 2 levels. Okay? So there's a whole variety of different languages available. We also get students who go and do things from the arts and social science faculty, so there's a philosophy module students fancy. One of the things I would say is that because there's a huge first year in the university, the business school are not interested in teaching business to first year students. Okay? So we get students who want to do a business module or an economics module, and unfortunately, I love that you could go and do an economics module, but the economics department don't really want to have to deliver on that, sadly. Lots of choice. You've got to take 40 credits, and these are all 20 credit modules, so I'll make life easy for you. 2/3 of students do molecules in action, and 2/3 of students do a module called single mass set. So if you don't want any choice, do another chemistry module and a maths module that helps you understand the maths they're teaching. If you want to go and do a language, if you want to go and do sports psychology, you can do that instead. So what does this first year add up to? You've got 7 lectures a week for chemists. Not all of those lectures are being taken by chemists alone. Some of them are being taken by chemists and natural scientists. So the chemists alone fit in this room. When we've got natural scientists, we need a large room across the corridor. You get a tutorial per week. There are 6 students in our tutorial doing work that we set you in advance and then discussing it in the tutorial. You get a problem class. That's a slightly large group of students going through a set of usually mathematical problems. You're in the teaching lab, which has 60 students doing a session twice a week, and you're doing your elective modules. Depending on what you pick, your total then is going to add up to about 20 or 23, 24, 25 hours of contact. You need to do some preparation for the tutorials, some preparation for the problem class, and some preparation for the lab work. But actually, what we also want you to do is, after I've done lecture 1, I want you to understand lecture 1 before I do lecture 2. So we encourage you to spend roughly an hour a week for each hour of lectures understanding the material before the next lecture. And as is always at this time of the year, most of you have brought a parent with you. The parent is probably working a 40-hour week to keep you at the university, and we tell our students we expect them to work a 40-hour week, and we even tell them to go home at Christmas and show mum and dad diaries and say, look, I'm doing a 40-hour week. Okay? The first years do not believe me. The third years will tell the first years that Dr. Hughes is right. Okay, second year. Second year will make you focus a little bit more on being a chemist. So in second year, we have 100 credits that are defined of inorganic, organic and physical chemistry, theory, work and practical. You get a choice still, and the choice is that you can do chemistry at the interface with biology. It's chemistry, it's not biology, it's the chemistry of biological molecules. You need to understand some biology vocabulary. Computational chemistry is using a computer and the theory to understand the energies, the shapes and the reactions of a molecule. And you can take a module from another subject, so you can still do a language or modules from other academic subjects. Depending on what you take here as your choice, you're looking at about 12 or 13 hours a week of lectures and workshops in second year. And on average, you'd be in the teaching lab for 10 hours per week. You'd be more some weeks less other weeks. Third is where the degrees become different. So I'll talk first a little about the four-year course. So the four-year course, we again have a module that's got an unexciting title called Core Chemistry, now 3. This thing that's got a very strange title, Chemistry Literature Perspective, to us, perspective is a fancy word for a short dissertation. Why don't we call it dissertation? Because that word's on the next slide. This is go and read some literature and write about it. It's developing your literature writing, your science writing skills. We have modules in inorganic, organic, physical chemistry, theory and practical work, and then an opportunity to carry on building your own choice of do I want to work at the interface with biology, at the interface with physics, do I want to do materials, do I want to carry on developing my language skills. Okay, so this is the point at which people can still develop their choice of where they're focusing in third year. The third year students doing a bachelor's degree, this is their final year, and the university expects every student in their final year to be able to demonstrate their research skills. So again, you do core chemistry 3, but now you do something called the dissertation. You go and read some literature, and you demonstrate what research skills you've got in terms of understanding that literature. So it's a bigger piece of work. And it's supported by these other two modules that develop your research skills. Again, modules of inorganic, organic and physical chemistry, and again an opportunity to work at whichever interface you want to work at. Now, by the time students got to the end of the third year of a BSc, they've usually decided that their career is not going to be as a chemist. And this is the point where they suddenly realise, well, you said I could do a language in first year. But they just chose the easy route and did maths and chemistry. And now they suddenly realise they want to develop a language, or they'd like to actually do an economics or a business module, and in third year the business school will let students do a business module. So at this point there is an opportunity for the students on the BSc to go and do a language module, to go and do a sports psychology module, to go and do a module in management from the business, and get the skills that they realise they're going to need when they go out and leave. The skills they could have probably developed from the first year, but they didn't realise in first they were going to need. Most of our students do a four-year course, and most of them do their fourth-year project in Durham. So this slide defines the end point for most of our students. You go into one of my colleagues' research labs and you work on a research project that nobody's worked on before, or where you make a contribution that's not been done before to a bigger project. So I have colleagues who will do things like they've got a crazy idea and they need someone to try it out. Well, you try it out. If it doesn't work, you learn a lot of skills. If it does work, you get your name on every paper that comes out of that group for the next 10 years. I have a colleague who for about 10, 15 years, every single student he put onto a small part of a project that was an ongoing project. And every single student who did the fourth year project with him got their name on a paper for a small contribution to a bigger piece of work. Okay? So you get a variety of different contributions that you can make to scientific knowledge. So a real opportunity to do research that nobody's done before. So that runs for 20 weeks, 15 to 20 hours per week. So that's the first 2 terms, and then you write up and reassess it. To go with that, you're doing 2 modules of lectures. And here are the 2 modules of lectures. And at this point, we really are trying to get students to understand things that do the search interface. So I guess one of the questions people often ask me is, do you have a degree in medicinal chemistry? And the answer is no, we've chosen not to run a degree in medicinal chemistry. What we've chosen to do is to let you go and do modules in biology in the first year. You can do modules in biological chemistry and advanced biological chemistry in second and third year. And then in the fourth year, we will actually teach some medicinal chemistry. So I have an organic colleague who teaches about how we discover drugs. I have a colleague who worked for GSK who will teach you how, having got a hit, how you get it to market. I have a colleague, we've long had a number of people in the department who have worked on inorganic metals applications to medicine, so we have electricals for metals in medicine. The structure is you're choosing 4 from the left and 4 from the right. Sustainable green and green chemistry is obviously something that we're going to have to build on going forward, because one of the, I didn't say this in the first lecture, I'll say it now, okay? Sort of one of the dawning realizations is, you guys are not, so this is the students, not the mums and dads, you guys are not going to get a pension until 2070. So if we say it's roughly 2020 now, it's not. 2020 to 2050, you can spend half your working life working towards net zero, and half of your working life living in net zero. Okay? You guys are going to have to learn to make a contribution, because I and mums and dads are not going to be doing much towards getting us towards net zero. Okay? So this is the point why I call this out. There's a power source in here. We all call it a lithium battery. It's not. It's a lithium-ion battery. Piece of real chemistry for you to understand. There's no lithium in this. There's lithium ions. Explain to your parents who aren't chemists afterwards what I mean by the difference between the lithium and the lithium ion. Okay? Li plus in here is moving from one side of an electrochemical cell to the other side. That chemistry was all being developed in Oxford 40 years ago when I was an undergraduate. Okay? You guys are going to have to develop the next set of technology that will get us to 2050 and get you to a pension in 2070. So I won't be around in 2070. Okay? This is going to be important. I have a colleague who has a job in chemistry and a job in physics, and he works on molecules at very low temperatures, fractions of a millikelvin, temperatures at which you get interesting quantum mechanical effects. So he teaches electricals to the fourth year on cold and ultra-cold molecules. And when you do that, you call the module Advanced Research Concepts in Chemistry. Getting a bit warm for the joke. Okay. So that's the fourth year if you do your project in Durham. If you want to go and do your project away from Durham, we offer 2 options. One is to go and do a project in industry. So you go to a company, you do a research project, you write it up, bring it back to us, and we read what we're allowed to read and assess it against the same criteria. Meanwhile, you are doing core chemistry 4D. If I remember which one I want to do, I did that one. That one. That's the courses on the left-hand side. So you spend your third year applying for placements. You go and get a job with a company. We changed these numbers yesterday, increased them, because my colleague who is the placement tutor said that's what the salaries are this year. So 2 tax years, you can call it tax-free. It's very attractive. We sent people to a variety of different companies over time. Mitsubishi Chemicals is 20 miles that way, so is Johnson Matthey. AstraZeneca is in Macclesfield or Sweden. AXA Nobel is ICI Paints. You do not get to spend the year watching paint dry. See, watching paint dry is not chemistry research. Making a batch of paint with an additive, measuring the drying time. Different batch of paint, different additive, measuring the drying time. And then trying to connect the drying time with the additive. That's research, okay? Just doing routine chemical work we don't allow people to do. What have we got? So Procter & Gamble, if I go down and, not Procter & Gamble, Johnson Matthey, if I go and visit the students who are at Johnson Matthey on Teesside, the supervisor did this degree 10 years ago. Okay? And stayed there. It really does impact on your employability prospects. Okay? And then the last one on the list, WASH. Well, WASH, that is in Switzerland, and so you can turn this into different numbers in a slightly harder currency. The companies that offer placements tend to be pharma doing organic chemistry, polymer companies doing polymer chemistry, and other people wanting physical measurements. I'm synthetically an organic chemist. I barely feature amongst these chemicals companies, okay? Maybe Johnson Matthey's catalyst department. This really does improve your employability prospects. Notice we are sending students away in fourth year rather than sending students away in third year. Part of the merit is that means we're sending better students than other universities. That helps you because the companies realise that our students are better. You're more likely to get a placement. The other option is to do your fourth year project overseas. We don't send students to go to an overseas university in their third year and listen to someone like me doing organometallic chemistry in French. Okay? We don't choose to let you do that. We choose to send you in your fourth year and to listen and to go do research. The international language of research is mostly English, and so you need the language in order to be able to live in the foreign country, buy a train ticket, food, and a beer. That would be a cold one. You will be 18, so it will be legal. Okay? So again, you go to an overseas university, you work on a research project, you bring it back to us, we assess it against the Durham-based criteria, and you are doing one of the modules by distance learning. We sent people over time to a variety of different places in France, Spain, Germany, Italy, the Netherlands, Texas, Argentina. Perth is the University of Western Australia, the most remote city on the planet. So the first student who went there, we were adamant that every time we go to a new university, we have to send a member of staff. So we picked the colleague who spoke the language, and we sent him to go and visit a student in Perth. He didn't come back. Actually, not quite true. He did come back, and 6 months later, he took up a job at the University of Western Australia in Perth, which means he's only a 3-hour flight from his parents in Adelaide, rather than 24 hours when he was living here in Durham. Okay? That does mean if anybody else wants to go to Perth, I'm not sending another academic. But I don't need to, because the deputy head of the department in Perth had the office next door to me for 10 years, so I can trust him to look after the students. Okay? You can guess what happened when we sent a student to Tokyo and sent a member of staff to visit with a Japanese wife. Okay? That member of staff no longer works for us. Going overseas really does improve your employability skills, it improves your independence, it improves your language skills, and actually, probably a significant proportion of the students who've gone to overseas universities have stayed there to do a PhD afterwards. Okay, so that's the structure of the degree. What do the people do who've done that degree? I apologise, the numbers here are getting a bit old, but it's about a week's work to compile these data, so it takes a lot of enthusiasm to get around to redrawing this graph. And I don't think the graph would look different if I was to redraw it with fresh data. So when you ask people 6 months after they graduate, a long time ago, what they're doing, about a quarter of them are doing a PhD. That could be in Durham, it could be somewhere else. If I look at all the PhD students in Durham, what they do after they graduate is they go into work and further study, usually as a chemist. Undergraduates go off and do 1-year postgraduate qualifications. We have people who go into teaching. We have people who go directly into chemistry employment. That's where a lot of the PhDs are going afterwards. We have people who take their study skills, their numeracy, their literacy, their analytical skills that we have developed, and they go into other graduate level careers, law, business, finance, other things that I couldn't fit in a box. At 6 months after graduation, there are people working at non-graduate level, there are people who are unemployed, and these are the ones who are doing a Swiss ski chalet season, or are playing cricket in Australia as sports coaches. Okay? It always terrifies me at graduation how many tell me in front of Dad that I'm going off to travel the world, and I can tell you the data 6 months later turn out to be completely different. usually because between graduation and asking people what they're doing, Dad has changed their minds. The data may be old, but actually I've seen more recent national data and they aren't very different. Okay? So then, I guess the scary slide. So you want to come to Durham to do chemistry, what have you got to get? We make an offer of an A star and 2 A's. We require chemistry and we require A-level maths. We have required A-level maths every year for the last 15 years. We do not have a makeup course. We can't take people without A-level maths. Once we make you that offer, you can get the A star in chemistry, maths, or French. Okay? Any academic subject. We never make higher offers, that's university policy, and somebody asked earlier on, so this year we had 473 applications, made 384 offers, and that is to get 87 students to turn up in October. Why do we make 4.5 offers to get one person to turn up? Well, you're making 5 applications. So at 4.5 we're beating the statistics. A large proportion of our applicants have applied to study chemistry at a university on the banks of the Thames. A large proportion. Okay? And if you get an offer from that university, you're not going to turn it down to come here. I've seen that twice in 20 years. So lots of people apply to Oxford and also apply to us. And if you get an Oxford offer, you're not coming here, so we've got to make you an offer anyway. We really honestly cannot see where else you apply until you have made the decision as to where you're going. At the point where you're filling in an application form, we cannot see. Okay. So at 4.5 offers per place, we're actually doing quite well. The offers don't include anything non-academic. They don't include EPQ, largely because people cannot be guaranteed that they can do that at each and every school. We're very happy to treat maths and further maths as 2 different subjects. They're not 2 different subjects, but we treat them as 2 different subjects. Both my sons did maths and further maths. If you're doing further maths and aiming at an A or an A star, then maths is not an A level. It's an advanced GCSE. But never mind. We make some offers of 3 A's and we effectively take some people who get 2 A's in the B. If you're doing 4 A levels, then the offer is an A star and 2 A's in chemistry, maths, and any third subject. So you can get the other A or A star in either of the other 2 subjects. And here are some offers in other qualifications. Okay, so I've been doing this job 20 plus years. So I spent the first 15 years reading UCAS forms. I've read 8,000 personal statements in my life and written 3. Mine, and I've already told you, I've got 2 sons. The admissions process now is that I define criteria and somebody centrally applies those criteria. What are they looking at? They will read every personal statement, they will read the teacher's reference, but principally they're looking at your prior and predicted grades. They will look at the contextual evidence that there might be for your merit and potential. They are looking for your motivation for the degree program, and they're looking for your study and other skills. But we are not rejecting huge numbers of applicants, right? Okay. Go back here, we're making offers to 384 out of 473. Largely it's your predicted grades, your prior achievement that provides context for those predicted grades. Okay, the other thing about Durham is that we have colleges. Use today to go and have a look around what that means. But from a chemistry department point of view, what does it mean? Now, when people talk about universities with colleges, they sometimes think they understand Oxford or Cambridge or York or Lancaster. They're all different and we're different again. Okay? So you come to Durham and join a college. Every student joins a college. Colleges will provide every first year with an opportunity to live in college managed accommodation. Colleges have a library which will have books and study space and a budget to buy more books. So if the book you want's not there, tell the librarian before the English language student who's the college librarian buys more novels. Colleges have IT facilities, so there's a network connection in your room. and there's usually some kind of study space that's got some computers in. Colleges provide a student welfare and support system that contributes to a very supportive environment. College is where you can get involved in anything that you want to do extracurricular, so whether that's sport, music, drama, charity work, whatever. Colleges provide you community spirit, and 3 weeks after you arrive, you'll tell everybody that your college is the best. And you will do that for the next 40 years of your life. Okay? But it's your choice as to which college you're going to apply to. Colleges provide an atmosphere that supports and encourages academic life, but in Durham, the colleges do not do any of the teaching. We in the academic departments do all the teaching, and in chemistry, we do not put anybody in groups based on college. 1 year we ran tutorials based on colleges. Students didn't like it. It's hard work to timetable. So we don't even bother to try now, okay? We don't do any teaching in college groups. So as the university's process now stands, you make a UCAS application to Durham to study chemistry, and then once you've got an offer, you are then invited to rank the colleges in an order of preference. You're invited to go to a website and put all 17 colleges in whatever order you want, and a computer will do its best to make as many people happy as possible. Okay? There are some colleges that are oversubscribed, and the colleges don't like me to tell you this, but I'll tell you how you work out what would be an oversubscribed college. Okay? An oversubscribed college might be a scheduled ancient monument, where you could reenact scenes from Harry Potter in a castle. Okay? The University College is oversubscribed. I don't think this one's true. Well, 10 years ago we had more students wanting to self-cater than we had self-catering. We've built 2 new self-catering colleges since then, so that used to be one thing that was a problem, but I don't believe it's a problem anymore. And the other thing that makes a difference is people who have not been to Durham and have not realised that to walk from here to the furthest college in that direction is 20 minutes. I know, because I live another 5 minutes beyond it, okay? And the furthest college in that direction is 20 minutes. This is a small city. Don't think you've got to apply to the college that's geographically closest to us. Because if everybody does that, which is what happens, the computer says no. Okay? The reality.